lesson 2.4, linear functions. And the objectives are, we're going to go over basic concepts of linear functions. We're going to go over slope-intercept form of a function. And we're going to go over slope. Okay. On your sheet there, a linear function is in the form f of x equal to ax plus b, where the main difference is the exponent for x, the power for x is x to the first power, x to the first power. That defines a linear function. Where a does not equal 0, because if it did, then all you'd have is a constant. And the domain and range are both negative infinity to infinity. No restrictions on the domain. As long as the linear function is not completely vertical or completely horizontal. As long as the function is not vertical or horizontal, then the domain and the range are negative infinity to infinity. Okay, let's take a look at the next slide. Slope measures the steepness of the line. The larger the slope, the more steep it is. So, for example, if you've ever gone up to the mountains, right? You start off like flat, and then as you get to the foothills, right, you start to slope up a little bit, and then when you get to the mountains, it starts to slope up even more. To where if you see like a percent gradient, mainly from when you're going downhill, like for example, 3% per gradient, that's slope, okay? That means for every 3 feet, you go horizontally, or every 3 feet, every 100 feet you go horizontally, you're going 3 feet down. So 100 feet, 3 feet, 100 feet, 3 feet. So the higher the percent gradient is, the faster you're moving down the downward, okay? So it's a ratio. Slope is a ratio of rise to run, where rise either goes up or down. Rise is a change in the y value or height, right? Up or down. Run is always going to the x or horizontally, and it's always going, for when we're graphing using slope-intercept, we're always going to the right for run. Rise can go either up or down based on whether it's positive or negative, but run always goes in one direction, to the right, when we graph. Slope is a change in the horizontal distance, like what we were talking about when we're going down the mountains, change in horizontal, and a change in the vertical. Should actually be the change in the vertical is delta y over the change in the horizontal, delta x. Okay, slope is rise. You can see this as rise over run. Delta y, or this triangle looking symbol means delta, or difference, or change in the y values. So slope, if you're looking at 2 points, x1, y1, and x2, y2, slope is y2 minus y1 over x2 minus x1. So it's the change in y values over the change in x. So change in y is your rise, change in the x values is your run, where the change in the x does not equal 0. Well, what happens if we have 0 in the denominator?
Isn't 0 in the numerator?
Yeah, in the denominator. In the numerator, it's 0. but in the denominator, it's undefined. Okay, we'll get more into that here in the lesson. Can we go ahead and put the cell phone away, please? Appreciate it. You what? All right. Okay. Slope of vertical line is undefined. So if the line is going straight up and down, that slope is undefined. There is no change in y. Okay? Just change in x. That's why the slope is undefined. All right, find the slope of the line given 2 points. All right, let's look at that. We've got -4, 8, and 2, -3. Okay, first thing we do is label these points x1, y1, and x2, y2. Okay? And then we write the equation and your slope y2 minus y1 over x2 minus x1. Okay, it helps to write the equation down every time because then you don't have to think so much about where the point goes, the value goes in the right place. Okay, y2, that's going to be your second y value, that's a -3, minus y1 is 8 over, so this is your change in your y values, right? Now we look at x2. Well, what's x2? 2, yeah. Minus x1 is a -4, right? So it's minus a -4. This minus is the minus for the equation. This minus is the minus for x1. So you got 2 negatives. Well, minus a negative is a what? Minus a negative is a positive, right? It's like saying the opposite of -4 is a +4, right? So minus a negative, it's like negative times negative, right? It's a positive. Okay, questions so far? Okay, so -3 minus 8, what's that? Yeah, -11, right? If you dig 3 inches down, and then you dig another 8 inches down, you're 11 inches in the hole, right? So it's a -11 over 2 plus 4 is what? 6. So our slope is a -11 over 6, right? So in other words, if you're starting from 0, for example, you're going to go down 11 spaces and then across 6. So it's down 11 across 6, down 11 to the right. Rise is a negative rise. Its rise is going in a negative direction for y. The run is 6, so it's -11 for rise, 6 for the run. Okay? All right. Questions there? All right, let's try the next one.
Are you recording this?
What?
Are you recording this for people that aren't here?
Was I born here?
Recording.
Recording? Yeah. Yeah, see, and right here, see, I'm recording on that, and then I edit it and put it on YouTube, and I put it on if you look here,
I think I seen one of them on black.
here's one of the videos right here. So I'm going to put more of them up there. I kind of need to catch up a little bit. I don't think the last one took. I had problems with the last video with the program that I'm using. So I don't think the last one. It may have, but I'll have to look. One of them I couldn't get recorded.
So you recorded Friday?
Yeah, I'm recording it right now.
No, I'm talking about every Friday, like every Friday class. You record every Friday.
All of them.
Really?
I mean, I have been lately. Yeah, I have been recording all of them. Yeah. Yeah. Okay. So you can always go back and look, right? So x1, y1, right? We label it x2, y2, and we put our equation, slope of 2 points equation, y2 minus y1. Now the y's are always going to be in the numerator. The denominator is always going to be, we always put the numerator first.
So, no, I'm saying, like, it doesn't matter if you put x2 or y2 first and then y1 or y1.
It really doesn't matter as long as whatever you put in first, like if you put y1 minus y2, then you got to put x1 minus x2. You have to do the same. Whatever you do in the numerator, you got to do the same in the denominator. Okay.
Now, hold on.
So it really doesn't matter which one's x1, y1, which one's x2. If you flipped it, that'd be fine. Only difference is the negative may end up being in the numerator instead of the denominator, but then you just put it in the middle anyways, and it's going to be the same then. Okay, good questions. All right, so y2. What goes in here for y2? Negative 4. Good, excellent. Minus y1 is 7. Good. Over 2 minus 2 again, right? Okay, so, well, hold on, slow down. The numerator is what? Negative 11 again over 0, right? Well, if 0 is in the denominator, it's undefined. That is correct. Undefined. So our slope is undefined because there's no change in the y value, right? It's a vertical line. There's no change in y, so it's undefined for slope. Okay? Questions there? All right, good work on that. Okay, let's try this one. Actually, I'm going to leave this one here and put the next one up right below it. So try this one, 5, negative 3, and negative 2, negative 3. All right, try that. Go ahead and work that out. And I'd like to have somebody come up to the board. And I'll check your work first. So that, yeah, exactly.
Yeah. Yeah. That's good. You want to go ahead? No, bad. You want to do it? Okay.
Well, let's see, it's negative 3 minus negative 3, right? Because you got the negative for your equation, right? So that's going to change it, right? Because your slope of 2 points equation,
right? Y2 minus Y1 over X2 minus X1.
Isn't that 6%?
So you got -3 minus a -3.
Oh, it'll be a positive.
Yeah, yeah. Okay,
So it's 6 over -7.
and then 2 minus 5. Okay, so do you want to finish that up? Okay, go ahead. You can do it right on here on the board if you want. You can do it right on here if you want.
Tell my hand gonna be on the court. $1 million fingers.
Okay, so he's going to get, so what is that, a 6 or a 0?
That's a 6.
But, okay, but you got minus and negative, right?
Yeah.
So what's
So
going
it's
to happen?
positive 6.
Positive. Well, hold on a minute now. That's -3 plus 3, right? Because this minus and negative is going to be plus,
so
right? So make that a plus. There you go. And the other one too. Right? Because minus and negative is a plus. The opposite of a -3 is a +3, right?
Yeah.
Is what you're saying. So you got, if you dig 3 inches down, and then you cover 3 inches up,
0.
0, right? Okay, so 0 over -7 is,
Undefined.
well, if 0 is in the denominator,
Oh,
it's
so it
undefined.
could be like
So
the
it's,
graph right here, and then 0 on the point, and then you go, I think maybe.
yeah, so it'll be, so it's going to be like a horizontal, it's going to be like a horizontal line, right?
Yeah.
So the slope is going to be 0. Okay? All right, thank you for
Sure.
presenting that. Okay. So when 0 is in the numerator, our slope is 0. When 0 is in the denominator, it's undefined. Okay? 0 in the numerator, 0. Slope is 0. 0 in the denominator is undefined. Okay, so our slope is 0. All right? So we get a horizontal line here. So if we were to draw this out, right? If we were to draw this on a graph, okay, we've got 5, 1, 2, 3, 4, 5, -3, 1, 2, 3. Here's 5, -3. And here's -2, -3. See, it's a horizontal line. Okay? And so that slope is 0. Okay? Because it did not move, it's not changing, the y values are not changing up, it's not changing down. Okay? So slope is a change in the y values as we're moving horizontally. But if there's no change in the y values, right, no change in the height, then slope is 0. Okay? Whereas if you're vertical, right, there's no change in the horizontal, there's no change in x. So you can't measure change in y over change in x because there's no change in x, so it's undefined. Okay. Slope equals 0. The slope of a horizontal line is 0. Okay, slope of a horizontal line is 0. Okay, so that's slope. Now we're going to take a look at graphing a linear equation. Slope-intercept form of a linear equation is y equals mx plus b. So here we're given an example of an equation where in this case 5 is the slope. the coefficient of x is the slope. So 5 is the coefficient of x, so 5 is the slope. And you consider the sign, whether it's positive or negative, with slope. The y-intercept is the constant, or the number that doesn't change, right? There's no x with a constant. It's just a number. So the y-intercept is a constant. In this case, you take the sign and the number, so it's -7. So the y-intercept as an ordered pair, as a coordinate point, is 0, -7. Okay? Questions with that? Okay, slope. Positive slope, the line slopes up. As you're moving from left to right, the line moves, the y slopes up. It's like going up a hill when you're going up a positive slope when you're going to the mountains. When you're coming back down from the top or the pinnacle, right, or whatever you're at, if you're coming back down the mountain, then the slope is negative. And the line slopes downward. So negative slope, the line slopes downward. 0 slope is a horizontal line. And that's just like the horizon. Think of the horizon, right? When you see like the sun setting and you're looking out into the horizon and you see that line of the earth, right?
Like you at the beach.
Yeah, or the beach, yeah. You have that line where the land is, right? And sky, or land and water, or water in the sky. That's the horizon, right? So think of horizontal and horizon, okay? So that'll help. Undefined is a vertical line. Undefined slope is a line straight up and down. And so where's 0 in a horizontal line? Is it in the numerator or denominator for a horizontal line? 0.
0 slopes on
Numerator, right. For undefined slope, the 0 is in the denominator. Good. Yeah. So it makes a difference. Okay, steps. To finding slope, here we're given an equation, -2x plus 6. And so we want to graph that and give the domain and range. Okay, so the steps. First thing you want to do is find slope, and that's rise over run. Okay, so all our equations are in slope-intercept form, so you don't have to worry about putting in slope-intercept form. They're all in there. Find the slope, it's rise over run. Then you're going to find the y-intercept. So we already did that, right? For this one, we said the coefficient of x was the slope, and our constant is the y-intercept. Okay, so in this case, slope would be what? For -2x plus 6, what's slope? Yeah, rise over run, but which number is it? Is it the -2 or the 6? It's the -2, right? You have to consider the sign with it too, all right? The y-intercept. What's the y-intercept here? The 6, right? Plot the y-intercept and always on the y-axis. The y-intercept is always on the y-axis. Always, 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 always on the y-intercept. Okay, common error students, they put it on the wrong axis. I missed that. From the y-intercept, plot the second point, and Okay, this should actually be up here. From the y-intercept, connect the points with a straight line. This should be up here. Oh wait, no, that's not. From the y-intercept, plot the second. Hold on a minute, let me back up here. Back up. Something's wrong. From the y-intercept, plot the second point. Okay, and then connect the points with a straight line.
So what are
Connect the points with a straight line. From the y-intercept, plot the second point using rise over run. Using rise over run. Rise. So plot the second point using rise over run. So if the rise is negative, you're going to move down. Run, you're going to move to the right. If the slope is positive, your rise is going to move up and then to the right. Plot the second point using rise over run. Yeah. Okay. So let's take a look at this one. And we have f of x is equal to negative 2x plus 6. Okay, so we know that our slope is a negative 2. So that means that this is negative 2 over 1, which is our rise. We're going to move down to right 1. We're going to move down to right 1. Our y-intercept is 6. So our y-intercept is at 0, 6. Okay? Questions so far? Okay, so just draw a x and y axes on there. And so you're going to start with your y-intercept. So you're going to go up 1, 2, 3. Since it's a positive 6, you're going to go up 6, right? 1, 2, 3, 4, 5, 6. Okay? So you're up here at 6. Okay? And from this point, okay, use black, you can see it better. So from this point here, y-intercept, you plot that y-intercept, plot that point. To get the second point, you use the motion of your slope. Down 1, 2, and right 1. Okay, and so that's your slope. So you forever, down 1, 2 to the right 1, down 1, 2 to the right 1. Your slope is always going to be down 2, right 1, down 2, right 1, down 2, right 1, down 2, right, forever. Okay? And so that's why we put arrows on both ends, because it continues on indefinitely. I need to close this door. Okay, any questions with that? All right. So that's what that graph looks like. And the domain and range are both negative infinity to infinity. The line is going to keep going up and up and up and to the left forever, down and to the right forever. So our domain and range, so we can say that our domain is negative infinity to infinity, and the range is also negative infinity to infinity. Range, remember, is the change in the y values, right? So that's going to keep going up and keep going down. So that's negative infinity to infinity for y, and it's keep going to the left. So that's negative infinity. It's going to keep going to the right, so that's positive infinity. Okay? Questions there? Okay. I want to add a problem in here. Okay, so to the right, add this one, or in a space. So we're going to add this one here, because it'll help you on the homework. Okay, add, and we want to graph f of x equals to 1/2 x minus 3. Okay, so we're going to graph this one out. Okay, so we have to identify slope, and we have to identify the y-intercept. So what's our slope this time? Yeah, 1/2, right? It's the coefficient of x. It's always the coefficient of x. It's 1/2. So that means it's going to go, it's because it's positive, is it going to go up or down? Up. It's going to go up 1 and right. Yeah, it's always going to go to the right. 2. Now there's another way to do it where you work the x-intercept, x values, and then the y. But we're always going to start with the y values going up or down. So that means the run is always to the right. Yeah, -3. So our y-intercept is 0, -3. Okay, questions? All right, so we want to graph that, right? So where do we start? What point do we start with?
-3.
Yeah, we always start with the y-intercept. Always start with y-intercept. So when we have an equation, we find slope and the y-intercept. So you're always going to start with a point, in this case the y-intercept. So here's -3, plot that point. It's always on the y-axis. And now we said we're going to go which way?
Go
Up 1, up 1, right, 2. So this is up 1, right, 2.
That's the slope.
And that's our slope. So it's going to go up 1, right 2, up 1, right 2, up 1, right 2 forever. Okay? And that's our graph. So notice it's a fraction, right? So the fraction is going to make it flat, kind of like flatten out. So it's like you're going up the, if you're going to the mountains, it's like going up the foothills. The slope is not very high, right? Okay. All right, so that one's not on the graph. Okay, here we have graph f of x equal to -3. Now, here, this is a little different because notice there's no x. Okay? F of x equal to -3. Now, in the last one, the domain and range is still negative infinity to infinity, right? So here, this is the same thing, since we know that f of x and y mean the same thing. Okay, f of x and y mean the same thing. So we can rewrite this as y equals to -3. Now in this case, I like to use the table of values. If you're not sure how this is supposed to look, you can always use the table of values. Okay. And since this is y equals to -3, the -3, is that going to go under the y or the x?
It's gonna go over one.
Under the y, right? Because y is -3 all day long, right? You could put anything for x, -2, I always like to use 0, and let's say +2. So if you graph it, right, then you're going to have, use green this time, -2, -3. Plot that point. 0, -3, 2, -3. So we get what kind of line? Think of horizon.
Undefined.
Well, is it horizontal or vertical?
Horizontal.
It's horizontal, right? Think of horizon. So with a horizontal line, did the slope move up or down? It didn't, right? It's like Florida, right? It's like Greensboro, right? Where there's no hills, right? Have you ever been to Florida? Who's from Florida? Anybody? Okay, I lived in Jacksonville for 10 years. So I know Florida is flat, right? So Florida has a 0 slope, right? So that's one way to remember it. So our slope is 0, okay? Now our domain is still -infinity to infinity. But the range does not move up or down. Here's range, right? Range are the y values, right? Well, if you erase everything where the line is not, all you're left with is a single point. Well, where is that single point? Where's that single point at? Where's that single point?
Is right there.
-3, right? So your range is -3, and it's a bracket, okay? So it's only a single point for the range. I need my end didn't come out too well. There we go, that's better. Questions there? So this is what I was talking about, where domain and range are -infinity to infinity, except for where the slope is either horizontal or vertical. Well, this is what I was talking about, where here the domain is -infinity to infinity, but the range is not. The range is a single number. Okay? Questions with that? Okay. So there we go. All right. So now, kind of wish the slide used a different number besides the same number, but that's okay. All right. We want to graph x equal to a -3 and give domain and range again. Okay. So there's no y this time, right, or f of x. So again, we can use the table of values. Now, where's that -3 going to go, under the x or the y for our table? X, right? X. X is going to be -3 forever, right? Y can be anything. -5, 0, we'll use -5 and +5 this time. So if we graph it, right, x is -3, -5. 1, 2, 3, 4, -5 for y. -3, 0. And x is -3, y is +1, 2, 3, 4, 5. So what kind of line do we got this time?
You got a vertical.
Vertical line, right? And vertical line, the slope is Undefined, right. Slope is undefined. What? Slope is undefined. Well, the domain is, if this is our domain, right, and we erase the line where the line is not, you only have a single point, right? Well, where is that single point? Well, what is that? Domain is what? What is this x value right here?
Yes.
-3, right? Domain is -3. The range, y, is going unrestricted, what?
It's going to be 0.
Negative infinity to infinity, right? Okay. So again, I was telling you that if the line is vertical or horizontal, you won't have negative infinity to infinity, negative infinity to infinity for domain and range. This time, only the range is all real numbers, right? Or negative infinity to infinity. The domain is a single number, and you just have to look at what that is to see what that is, right? Okay, questions there? Alrighty. Okay, we were given an equation, and we had to graph that. Now we're given a point at -1, 5, and a slope of -5/3. Okay, so in this case, what we do here is we start with this point. Okay, we start with this point. We don't have a y-intercept, but we do have a point. Okay, and that point is at -1, x is -1, y is 1, 2, 3, 4, 5. So this is, we plot that point, -1, 5. Okay. Now here, the negative, look up here, the negative is always going to go with the numerator. Negative always goes with the numerator. So that means this is going to go up 5 or down 5. Our slope.
It's going to go, no, there.
It's negative, right? So it's going to go down 5. So the negative always goes with the numerator. Even if it's off to the side like this, the negative always goes with the numerator. So it's going to go down 5, and yeah, and then right 3. That is correct. So here, we started with this point, and we go down 1, 2, 3, 4, 5, and to the right 3. 1, 2, 3. So actually that's a 2.
So
This is actually 2 here because you started 1 to the left. Okay, so you join these points. Okay, so that slope forever is going to go down 5, right 3, down 5, right 3, forever. Okay, that's why we can start at this point right here. We don't need to start at the y-intercept. We can use any point. It's just that when we're given an equation, we use the y-intercept as that first point. Okay? All right. Questions there? All righty.